Well, hello friends. Welcome to another video math lesson with Mr. Thompson. Right now we're looking through the solutions for the Chapter 4 practice test on linear relations to prepare you for the test. If you don't have a copy of the practice test, you can download one at www.tinyurl.com/year9mathnotes, YR9 math notes. Click on Chapter 4 and then head over and get the Chapter 4 practice test. Right? Okay, let's get right into it. So the first thing we need to do is label some parts of the graph. Okay, the first thing is the quadrants. First quadrant is easy, so we put a number 1. Whether you do a Roman numeral or a number, doesn't really matter. Number 1, top right-hand corner, where everything's positive. From there we go anti-clockwise or counterclockwise, 2, 3, and 4. Okay. Then we put a dot to label the origin right there in the middle. Okay. Number 2, we are going to identify the intercepts. Now the intercepts are the place we have this line going through here, right, down this way, and we want to know the intercepts are the place where that line intersects the axes, right, the x-axis and the y-axis, right? So I've got a couple of points I've drawn in there, blue dots, where the line intersects the axes, and the x-intercept looks to me about 7, and the y-intercept looks to me to be about 8. Okay. Now each of these can be written as a set of coordinate points, right? 7, 0, and 0, 8, but just the numbers 7 and 8 are fine too. Okay, the next one, we need to find the intercepts. We don't have a picture this time. We have a rule, right? 2x plus 3y equals 15. So to find the x-intercept, we need to set y equal to 0. So we rewrite the rule with 0 put in for y. Now 2 times 0 is 0, so we can just get rid of that and it becomes 3x equals 15. And then we're going to solve for x, so we divide by 3. The 3's cancel on the left, and 15 divided by 3 is 5. So the x-intercept is 5. To get the y-intercept, we let x equal 0, and do the same thing. We plug in 0 for x. 3 times 0 is 0, and 2, so we get 2y equals 15. So we divide by 2. 2's cancel out, and we get y equals 7.5. Okay, so that's our y-intercept. Now we go ahead and plot those points. So on the x-axis, we plot a point at 5. And on the y-axis, we plot a point at 7.5, right, 7.5, and then we simply draw the line through those 2 points. Okay. Some graphs here that only have one intercept. X equals 4, right? I'm going to color code my lines here. It says to label. So if you want to color code yours, that's fine, that works. Or you can label each line A, B, and C. I'll do orange for x equals 4, and I'm going to put a dot at x equals 4 on the x-axis, and then I just draw a vertical line. Okay, for B, I'll use purple, and I'd put a dot at -2 on the y-axis, and draw a horizontal line. Right. For part C, I have the equation y equals 3x, and this kind of equation, I know, always goes through the origin, so I'm going to put a dot at the origin, and then I'm going to find another point. By plugging in a number, and the number I'm going to plug in is 1, okay, and that's usually the easiest one to do. So we let x equal 1, and so we plug that in here, for x, and we have 3 times 1 is 1. So then y would equal, 3 times 1, and 3 times 1 is 3. So we have x equals 1 and y equals 3, which gives us a coordinate pair, a point, right? 1, 3. So I go ahead and plot that point over here on my axis. Okay, and now I have 2 points, and I draw the line between those 2 points, and I'm done. Here we need to determine the slope or the gradient, right? And it's not too tricky. Slope is rise over run, as we'll see here. So there's the run. If I start from this point here and go across underneath the other point, that's my run, and then I have my rise. Okay, which is how you find gradient, right? Rise over run. So we went over 6 and up 2. So the rise is 2 and the run is 6. Now I can simplify that to be 1/3, and that's the answer. Another way to do these problems, I could have done this for the first one, but for another way to do these problems, I can look at the coordinates, right? -1, 5, and 2, 1, and I can plug them into this gradient formula where I subtract the y's and divide by I subtract the x's and I divide, right? Divide by the difference of the x's. So the y's for this problem are 1 and 5. So I'm going to have, and I'll name my points, point 1, point 2, so we can correspond with these numbers here, y2 and y1, x2 and x1 if you want. So y2, the y from the second point is 1, and y from the first point is 5. So I'm going to do 1 minus 5, and then divide by the difference of the x's. So 2 minus -1, right? 1 minus 5 is -4, and 2 minus -1 is the same as 2 plus 1, which is 3. So the answer is 4/3. That's simplified, and so I'm done. And of course, you could have just done your, looked at the picture and done rise over run. When this comes in handy is when you don't have a picture. Okay, you can draw one, of course, but you don't need to. You can just use the formula and go for it. Okay, we want to give the gradient and y-intercept of each of the following equations. Okay, now these equations, the easiest way to do this, or one easy way to do it, is to put these in gradient intercept form, y equals mx plus b, right? So this one is already in gradient intercept form. So I have y equals 3x minus 2. The gradient is m, right, the number in front of the x. So the gradient is 3. The y-intercept is that number that's hanging out at the end there. So in this case it's -2. So you'll notice the formula for gradient intercept form has a plus there, and our equation here had a minus. So I just went ahead and changed it to plus -2. Okay, so that's an easy way to see that the answer is -2. You don't have to switch it to plus, negative, adding a negative. You can just know that whenever there's a subtraction there, it's a negative intercept. Okay. Part B, this is not in gradient intercept form. This one looks a little more like this, y plus mx equals b. So that does not work. We can't just look at the number in front of the x to get our gradient. We want to swap this around. We want to move that 1/2x over to the other side. And in order to do that, we're going to subtract 1/2x from both sides. Okay, which gives us y equals -1/2x plus 7. Okay, now we can see the gradient is -1/2, and the y-intercept is 7. Okay. Another problem like that last one, like part B from that last problem, if you have to put something in gradient intercept form, this is just an extra problem, it's not on the test, but one kind of problem you might see where if there's a number in front of the y, it gets a little bit tricky. First you need to do, like we did before, subtract 8x from both sides, so you get 2y equals -8x plus 4. And then we need to get y by itself, so we're gonna divide by 2, right? But we have to divide both sides, the entire side, by 2, not just part of it or just the x or just the number or anything. We have to do the entire thing. So the 2's cancel on the left, and we get y equals -4x plus 2, because that -8 was divided by 2 to give us the -4, and the 4 gets divided by 2 to become +2. Okay, and then gradient is -4, intercept is 2. Alright, here we're going to sketch some graphs. These are in gradient intercept form. The first thing we're going to do to graph these is graph the y-intercept. So my y-intercept here is 4, okay, so I plot a point on the y-axis at 4, and then I use the slope to find another point. The slope, the gradient here is -3/2, so I have a rise of -3, so I go down 3, as you can see with these red dots here, and then I go over 2, right? And I plot another point there. I now have 2 points, and I just draw the line between them. Okay. Same thing with this problem down here. I'm going to put a point at -6 on the x-axis for my y-intercept, and then my gradient is 3, which is the same as 3 over 1, which gives me my rise and my run. So if the number for the gradient is not a fraction, you can just put it over 1. Okay, so I go from my y-intercept where I started. I go up 3 and over 1. Okay, and I plot a point there. And then I have my 2 points, so I draw a line between them. Okay, a couple more problems here. We have a segment with endpoints at 2, -4, and -5, 8. So we want to find the coordinates of the midpoint. In order to do that, we're going to look at the x's and the y's. We'll average each of those. We'll find the mean of the x's and the mean of the y's. So to find the mean, we add them together. 2 plus -5 for our x's. We divide by 2, and 2 plus -5 is -3. So it's -3/2. That's simplified. That's good to go. You can rewrite it as -1.5 if you like, but you don't have to. -3/2, I actually prefer that, but it's up to you. Okay, then we do the y's. So -4 plus 8 over 2. -4 plus 8 is going to be 4, and divided by 2 is 2. So our midpoint is going to be a point. It's going to be a coordinate pair, an x and a y. And I like to just call it m because that's what midpoint starts with. So our x in this case is -1.5 or -3/2, and our y is 2. All right, easy. To find the length, we're going to use Pythagoras' theorem, right? A squared plus b squared equals c squared. So to find a, we're going to subtract the x's. Okay, so our -5 minus 2. And we get, and that is 7. Okay, to find b, we're going to subtract the y's. So 8 minus -4, which is like 8 plus 4, so that's 12. And then we plug them into our Pythagoras theorem formula. So we're going to square them, -7 squared and 12 squared. And we get positive 49, because negative times a negative is a positive, and 144, which added together is 193. And if you plug that into your calculator, you'll get 13.9 to the nearest tenth. Okay. Now, last problem. We want to find the perimeter of this triangle. If you'd like to draw it, you can. Go ahead, but you don't need to. To find the perimeter, we're finding the distance between each of the points, the lengths of the sides, and adding them all together. We're going to do the same thing we did before. Okay, use Pythagoras' theorem between each of these points. First from A to B, and then from B to C, and then C to A. So it's like the previous problem we just did, but we have to do it 3 times and then add everything together. So I'll do this pretty quickly. To go from the distance from A to B, we subtract the y's, so 2 minus 0, and we get 2. Subtract the x's, right? 6 minus 3, okay, and we get 3. We're going to square those, add them together, and we get 13. So from A to B, it's the square root. We have to take the square root. The square root of 13, which is about 3.6. Okay. Then from B to C, we're going from this pair from 6,2 to -1,5. So we subtract the y's. 5 minus 2 is 3. -1 minus 6 is -7. Plug those in, square them, and we add them together and get 58. So from B to C is the square root of 58, or about 7.6. Finally, from A to C, or C to A, either way, we're going to subtract the y's, subtract the x's, square them and add them together, right, and take the square root, so the square root of 41, right, which is about 6.4. And then, now we have these 3 distances, from A to B, B to C, and A to C, right? We're going to find the perimeter, so we have to add them all together, and we get 7.6, and that is the answer. Alright, so good luck on the Chapter 4 test. Just hit replay if you want to see any more of those. I'll see you next time.